The broadcast is now starting. All attendees are in listen-only mode.
Hi, good morning, everyone. My name is Travis McGrath, and thanks for joining us on today's Exago Support Lab. Today we have a great topic in store. We're using a piece of our extensibility offerings called our scheduler queue. We're going to go through a full code example and talk through not only what it is, but really show a working example. Just to make sure everyone can hear me, I see a lot of familiar names in the attendees list, so this is probably something you're used to by now. Everyone here is on mute, but we want to encourage you to ask lots of questions. So to make sure you can see my screen and hear me all right, please type a yes, a hello, how are you in the questions panel on the bottom right. One of my colleagues, Tom, is going to be doing backup on questions, so you'll probably get responses from Tom. If there's something that's specifically useful for the group, if you need me to back up, explain something a little more detail, use that questions panel on the right there to let me and Tom know, and we can absolutely accommodate that. We may push questions for later on, but as always, we want you guys to get as much out of it as you possibly can. Great, lots of hellos and good mornings, that's perfect. Awesome, so today's topic is the scheduler queue, and it's gonna be technical. We're gonna go into Visual Studio and dive into some C# code. We're gonna look at one database table, so we're not gonna do too much SQL, but just a little bit. Awesome. The other thing to mention, of course, is like all of our support labs, this will be recorded and posted on our support site. So you can always go back and review this topic or any others. And particularly with this lab, we're going to be releasing some additional downloadable code. So the code we're showing here is actually going to be something that you can download, install, and set up on your own machine so that you'll have access to it as well. Awesome. So with that, let's dive in. What's on the agenda today? So before we can talk about how to extend the scheduler capabilities, we have to talk about what the scheduler is to begin with, set some understanding of what it's used for, its various pieces. Then we can talk about the scheduler queue. Once we understand what it is, we might want to know why would you use it. So we're going to talk about what the benefits of doing this additional extensibility component and implementing it are. And then we're going to talk about how you would do it. So what's the architecture, what's the setup? And then once obviously we now understand what it is, why you would use it, and how you would use it, let's actually look at it, right? We'll dive into the details. Pretty simple agenda from here. Before I jump in, just want to pause, make sure there aren't any other questions. Awesome, perfect. Okay, so to start with, the scheduler. So when you install Exago, there are actually three components, and we've talked about the other two components at length. We've talked about the web application with all our front-end facing labs. We've talked about the web service API when we've covered the REST API and batch REST and all those REST things. So the third component is our scheduler. Its primary use is for emailing or archiving. There are some industries, obviously, where reports and data can't be sent via email, so instead they can be archived and saved. So those are the two primary uses, is setting up recurring patterns of automatic emails that get kicked off and then either emailed out or archived. It can also be used for something called remote execution. And we've talked about remote execution in the past as well, but effectively what it is instead of having the Exago web engine running reports, you can have it send a job to a scheduler, which is installed on a different server, thus the word remote, and that scheduler will execute that report and then send back the output to the Exago web interface. So you can set up an array of schedulers for remote execution. Today, our focus is going to be on the scheduler queue, which is all about emailing and archiving. So the remote execution isn't going to come into play here, but since we were talking about the scheduler, I want to mention that it does have that use as well. Great. As I mentioned, of course, this is separate from the Exago web app. So when you install the Exago, you have the same installer has both components, but you can install them on one server, you can install them separately, so they can be on different servers, and you can install as many schedulers as you want. So particularly for what we're focused on, this is a key. If you have many schedulers, what we want to be able to do is use this queue in that particular case. So if you only have one scheduler, the queue, the feature we're talking about today, not a big deal. But when you have many schedulers, that's when it's going to come into place. And this is a key component here. Awesome. So important notes on the schedule. So out of the box, without any changes, our scheduler will work like this. When a user builds a schedule, and we've seen that before. Next month's lab, we're actually going to show the schedule front end from a user perspective. We're going to revisit that topic, so I'm not going to show that today. But when a user creates a schedule, whether that's an immediate email or a weekly or monthly or annual recurring report, it creates a schedule file. We're going to call those jobs. And that job gets assigned to the scheduler, or if you have a bunch of schedulers, it gets assigned to one scheduler specifically. And that one scheduler will save that job as a local file. So we'll see those as XML files inside of the scheduler itself. So what are the implications of having that one scheduler save that job? Well, it means if that one scheduler goes down, that job doesn't run, right? If that one scheduler, for whatever reason, okay, sorry. So a great question came in, and I just want to back up for 1 second. So the question came in, which is, why would you have multiple schedulers? So you could have multiple schedulers in a number of cases. So you might have multiple schedulers if you wanted to balance the load. So if you knew that I'm going to have hundreds or thousands of scheduled jobs running, and I want to be able to distribute them across multiple servers in order to load balance, you would set up multiple scheduler systems, scheduler installations for that reason. Okay, so you have multiple scheduler instances. Okay, perfect. So you have multiple scheduler instances. They save the job locally, but there's some implication to that, right? If the schedule goes down, the job doesn't run. If the scheduler isn't backed up and it goes down, let's say you have your scheduler on a virtual machine, you're using some cloud-based system or some virtual schedules that you're sort of spinning up and taking down. If those schedules, if they're not being backed up, could be lost. And you have some potential performance inefficiencies. So there's this interesting sort of performance implication where when the schedule is created, it's assigned to a scheduler, and that scheduler may already have other jobs that are going to fire at the exact same time. So you may have, say you have an array of 5 schedulers, it may just happen that scheduler 4 gets a handful of jobs that all happen at the same time, while the other 4 schedulers are sitting idle, right? At that particular time, maybe there's a bunch of schedules that run, right at midnight, but instead of distributing them across all of your schedulers, maybe one, just by the way when they were created and when they were assigned, maybe it has all of those at once, and then it has to queue them up one at a time while other servers are sitting idle or maybe just not working under the same amount of load. Right, so job assignment is based on availability when it's created, not at the time it's running. And this is just sort of our out of the box. Okay, and this last piece is where the queue comes in. So for the folks doing lots of computer science, right, we're calling this a queue because it is, it's not a stack. We're putting the first thing in is the first thing out. And particularly what we're doing here is we're setting up a way that you can tell Exago, hey, when it's time to save a job, here's some custom code, and we're going to go through a sample of what that code looks like with specifically named methods so you can know how to interface with it. But this code is going to handle saving those jobs, and it's going to handle assigning schedulers to those jobs, but the scheduler itself isn't going to hold on to that job any longer than when it's running it. So it's only going to say, hey, give me the job, I'll run it, and then I'll give it back. It's not going to try to hold on to it and run it every time that schedule job has a recurrence. Okay, so it's this piece of extensibility. It handles storing the jobs. It handles assigning them to schedules when they're ready to execute. So what are the benefits of doing that? Well, the first part is instead of the scheduled jobs being saved locally with each scheduler across all your scheduler installations, now the jobs can be saved into a database. They can be centralized, they can be easy to back up, and if a schedule goes down, the job isn't lost because it's in that redundant database that you're backing up and having sort of be part of your standard. As we mentioned up above with the implications of the out-of-the-box feature, the performance, there's a way to assign jobs when they're ready to be run. So your chances of having sort of idle or inefficient assignment of jobs go away because the schedulers ask the queue for a job when they're ready to run something. So they're always active, right? We're not going to queue up 5 jobs on one schedule while others sit idle waiting for work. They're going to take whatever the next available job is. So it improves performance. And then the last piece is, because this is a piece of extensibility, you can further customize it. So if you want to have particular schedules or some sort of indicator, maybe you have favored users that are, at different tiers, you could prioritize jobs, or you could do customization beyond just what's next. You could have a priority queue or other customization as you need. And that's true of all extensibility features. The example we're going to go into doesn't do this further customization because we want to keep it as simple and sort of generic as possible. And we're going to focus primarily on these first two. So just want to pause there real quick, scan through the questions. Great question came in, which is, how does this work in conjunction with the dynamic static config? And how would that work in terms of prioritization? So the dynamic static config feature won't have, which we've covered in a past lab, won't have any implication with the scheduler queue. What will happen is, as Exago is launching, of course, you'll have the scheduler queue configured in the configuration of the Exago web app. And then when a job is created, it will keep track of the session information that's relevant from both the static and the dynamic, sort of the effective configuration that will be bundled into part of the job that'll be stored in the database. So that dynamic static config feature, while also a performance benefit, won't interact with this in any particular way, but that's a good thing. Awesome. Okay, so the architecture. So for the example, we're going to write our queue as a .NET assembly. And particularly, since the queue needs to be reached, it can be housed in one single location, or what we're going to do is we're going to have this be a DLL, and then we're going to keep that DLL handy on each server with the Exago web interface. So the Exago web interface can say, if you have multiple web interfaces, so the web interface can say, hey, a user just created this job, here's the queue code, telling the queue code to go save it. And the schedulers need to be able to access that so that they can say, hey, I'm ready for a job. What's the next thing to do? So in this case, we're going to deploy that on each server. And we're going to configure both the scheduler to know to look for the queue and the admin console to look for the queue. So these are going to tell the web app and the scheduler. In both cases, we're going to configure those to look for that queue in question. Awesome. So looking at that as a diagram, here's how that's going to work. So our DMZ, sort of our web server, is going to be up here. Each Exago web instance is going to be on maybe its own separate server. Maybe you have these spinning up virtually and dynamically, but each one's going to be able to communicate to the scheduler queue DLL. And if you're using folder management, you'll obviously have it able to connect to folder management as well here. So your load balancer is distributing users across your web interface. And then the web interface, when a schedule gets created, tells the scheduler queue. The scheduler queue will tell the database. And then the scheduler instances, the things actually running those scheduled reports, will be on other servers out here. And they'll also talk to the scheduler queue. So when they need a job, the scheduler queue can go back to the database, get the next available job, and tell the schedule, hey, here's your job, run this report, send out the result via email or archive as you need. And specifically, we're going to go into this in just a moment, but the way our extensibility feature works here is we have specific methods. And so some methods are going to be called by the Exago web interface when jobs are getting created or updated. And some methods are going to be called by our schedulers installations. Those are going to be when you need the next job and when you need to tell the queue, hey, I finished with that job. Here's the next time it's running. Awesome. So specifically, right, the queue code is going to handle those handoffs. So we're going to handle saving jobs and updating jobs from the front end. And then the scheduler installation itself is going to use the queue to figure out what the next job it should run is and let it know when it's ready to run for more. Okay, so the last piece here, so the code itself, we're going to dive into it. As an extensibility feature, we have some specifically named methods that will be expected. We're going to go through each of those methods. I mentioned some of those methods are called by the Exago web interface, some by the scheduler. I think there's one method that's called by both. And in our case, all the methods are going to rely on the database to collect and retrieve schedule definitions. You don't have to use a database if you want to store those schedule definitions in some other capacity. Because this is a piece of customizable extensibility, you certainly can, but this is sort of the most typical example we've seen with our clients who have implemented it so far, and the one we envision most folks using, so we want to use this as our example. All right, so before I dive in, are there any other questions there? Okay, great. Don't see any questions. So the first thing I want to do is look at the database. Just because if we're having all this work to save things into a database, we should understand what's being saved there, what's being created, and what structure we're storing it in. Again, all of this could be customized if you need some other levels of permissioning or customization, but this is what our base example is going to use. So we have one table, we're calling it scheduler jobs. And here, it's pretty simple. We keep track of the job ID, so which job are you running? When's the next time it needs to be executed? And in this case, everything saved in UTC because we want to make sure we're not overlapping time zones or getting something wrong because of that. So everything across all of our servers is being calculated in UTC time there. The status of the job, so is the job run? Is it currently run? Is it in process? Is it waiting? Is it, did something go wrong? Did it bend, right? If it is being currently run, which service has it? So is it claimed by a particular service? When was the current execution start? Who created the schedule? Who last modified the schedule if it's been changed? We have a soft delete, so if a user deletes a schedule and we need to go recover it, when deleting, we're going to change this bit here instead of actually dropping the row from the database. And then we keep track of the content of the schedule itself. So what's the name of the schedule? What's the name of the corresponding report? What's the ID of the corresponding report? What's the definition of the report, as well as what's the definition of the schedule. This will have things like the recurrence pattern and any session-specific values that were set via the API. So effectively, all of this is really just going into one table. In this case, I just have a simple row as an example. So I have this schedule. The schedule is called Travis's Weekly Update. It shows me which report I'm using, the report's ID, the definition of the report, and then the full XML for the job. Great question. So question came in is, if you're using remote execution, say for a dashboard, would the dashboard send these to the queue? The answer is no. So remote execution doesn't utilize the queue here. Those will, as sort of immediate jobs, will go directly to a scheduler array. And in fact, in terms of configuring Exago, typically we recommend having a different scheduler installation for scheduled jobs like these and immediate remote execution jobs, so that the immediacy of those remote executions doesn't have to sort of conflict with these recurring report executions. Another great question came in, which is, can the ETL feature, which runs reports on a recurring basis, be run on the scheduler queue? I believe the answer is no, but I'm going to defer to my colleague, Tom. He'll check back with our team, and we can follow up with you there. And then a great question came in, which is, when a report is modified, does it also modify the schedule? And so the answer is yes, but there's going to be a setting that allows us to control that. So let's get to the code, and you'll see some of these answers. Okay, so we've looked at the database table, and then here, what I want to do is just very briefly, I'm in the admin console of Exago. and I want to show where you tell Exago to use the scheduler queue. So obviously here we're going to go to scheduler settings. We have the schedules enabled. We're showing which schedules we have. And in this case, we're saying where the scheduler servers are so that we can ping them if we need to. But we're also specifying our assembly. So in this case, assembly equals, and then the path to where our DLL and our code resides as our custom queue service. Great. And then in the scheduler instance itself, we're going to do the same thing here. So if I go to my C drive, just give me one moment here. And I go to that, the scheduler installation. So C program files, Exago scheduler. If I go in here, there's going to be our schedule XML definition. And in this case, I have our file here. I didn't fill out any emails, so my schedule locally isn't going to have the actual ability to email anything, but that's okay. But here, these are the configuration settings, and the important one is the queue service. So this tells the scheduler instance itself, hey, when you need to know the next job, look here, call this queue service. So those are the two steps for configuring the Exago admin, the web config, and the scheduler's configuration to use the service. Awesome. Okay, so with all that said, so now we've got the path to the DLL, we've got the Exago web and the scheduler both configured. Now we can dive, and we've got the database table we need. Now we can dive into the code itself. Again, you'll be able to download this program from our support site after this webinar. So we're just going to run through this. So first thing the queue does is it creates a class, and this is the class we're calling. And the class has a couple of things. We're keeping track of the database connection string. We're not compiling that into the code. Instead, we're pulling that out of a web config file. But we're specifying the type of connection string and the data source. And then we're keeping track of a couple of variables. We want to set these just to have them be explicit and configurable. And to the question about what happens when a report is updated, in this case, we have a Boolean. We're defaulting it to true because it follows the behavior of Exago's out-of-the-box feature. But if you want, you can say, hey, when a user updates a report, don't change my schedule. You could set this to false, right? So it doesn't have to be true, but our example is going to handle that update. And we're setting a max execution in case something goes over and times out. Okay, so we have a couple of specifically named methods. So the first one is the start service. And this is particularly to tell the queue, when a service is available and when a job is, when a server with the scheduler is starting. So when you restart a service, it will call the queue and say, hey, here's my name, I'm starting. And particularly if there were any jobs that the queue had assigned to that service and the service went down for whatever reason, this would reset those to make sure that they don't get marked as claimed when that service isn't actually running them. So here, this just is going to do some SQL to update the jobs, specifying that that service is no longer taking them there, right? The next thing you might want to do is get the list of jobs. And so this is going to start to get us into the front end when a user opens the scheduler manager in the Exago web interface. The web interface, of course, needs to know what are the list of jobs available to show that user. So it's going to use this get job list. And specifically, the scheduler manager has what's called a view level. So it can determine which jobs to show a particular user. So it's going to pass in that view level, the company ID, and the user ID. Those are mapped to parameters in the Exago web configuration. And so the queue is going to go back to the database. It's going to get the list of jobs from the database that particular user should be able to see. It's going to filter out any jobs that have been deleted. or look for jobs that haven't been deleted, I should say. And then it's going to return that to the user. So here, based on the view level, we're doing a switch statement. So for company view, for user level view, or for sort of all schedules, we're going to create SQL, and all we're doing is we're pulling some XML from each row to show the scheduler manager which schedules are available. And then once they're available, we're turning those XML, that returned sort of list of XML from a data table, we're just turning that into an array. Pretty simple here. Okay, so now back on the other end, these methods are in a little bit of a funny order. I think we're ordering them a little bit more alphabetically. So when a scheduler is ready to execute a job, so it's started, it's ready to go, and it doesn't currently have a job, it calls and says, hey, give me the next execution job. And what's going to happen is we're going to find the next execution job ordered by next execute date that is either its next execute date has already passed or it's right now, and its status is ready, and it hasn't been claimed by a service. So no other service has sort of claimed it. And of course, we don't want to look at jobs that have been deleted. We don't want to run jobs that have been deleted. So of course we have a filter there. We're going to get that job. We're going to update that job so that other schedules, services don't claim it. So we're going to set its service name. We're going to set the status to running, and we're going to say when we started running it. And then we're going to get the job XML, and we're going to return that to the service. So that way the service, so in one sort of, one instance, these three database calls, these three SQL statements, we're going to get the next job, we're going to claim the next job, and then we're going to get the ID of the next job, we're going to claim the next job, and then we're going to grab the full definition, and then we're going to return that to the scheduler service, letting it start, dissecting the report, knowing how to connect to the database, and then, running the job. And then from there, when a user creates a job, so we've talked about what happens when the scheduler needs a job. So going back to the front end, when a user goes to create a job, they're going to use the save job method. So when they create it, whether it's an immediate job or like an email now or a recurring pattern, what we're going to do here is we're going to save it. We're going to look to see if the job already exists, just to make sure we don't create duplicates. If there is already an existing job, we're going to call an update method. Otherwise, we're going to call save new job. And that save new job, as you might expect, is going to do an insert into the database to set all the information. And one of the critical parts here is that it's going to set the status as ready. So if that job is not being run, it's going to set that status over to ready. And then the save existing job, this is if someone's saving a job that's already there, if they're modifying it through the scheduler manager, this will update that definition, so it'll set the next run date, change the status, maybe update the report name or the schedule name, anything that the user specifically has changed. Okay, so running through, we just have a few methods to go. This won't be too much longer here. So if the scheduler manager needs the full job, so a user goes to edit it, so they've seen the full list, they say, oh, I found the schedule, I want to make a change to that schedule. Then we need more than just what we got before, so we're going to need the full job data. So this method is going to be called, again, by the front end. And using the ID of that job, we're going to say, hey, can you give me the full data for the job? And so again, it just goes back to the database and says, hey, give us the full job XML and send that back. And then the last piece, this is those sort of optional components. If a report is deleted, we want to delete the corresponding schedules. So here, what that's going to do is when in the front end a user deletes a report, we're going to go through and update and set is deleted to true for each of the corresponding schedules using that report. One neat part is here, we're referencing that report by ID. So if you have different users with folders and reports with the same name, don't worry, we're not going to accidentally delete the wrong schedules because everything here is ID based. I'm alluding to something I'll talk about just a little bit later on. And that's all we're doing there. Same thing with rename report. If a report is renamed, we have the report ID, we have the name of the report, so we're going through and updating the database record. And then, of course, when a report is saved, if we set that keep reports up to date method, we can go and update the report XML definition itself. So in the database, we'll have that report definition, and that'll be included here as well. So that's just a simple update statement in our SQL. And then finally, flush. So flush is a method that when executions happen, if you have reports that are deleted or appended and we want to clean them out, we want to set them so that they don't appear in the scheduler manager in the front end of the Exago interface. We can call the flush method, and that'll just tell you to remove those from the list. And again, we're doing that simply by setting is deleted to true. So if a user accidentally deletes or flushes a schedule, we'll be able to go into the database and recover them. If we want to, at some point, we could set a script or a database trigger of some age to fully sort of clean out and hard delete the content of the database that's been deleted, but that's not something we have set in place here. We're not too worried about it, but it's something you could add as this is an extensibility feature there. And that's really it. Those are all the methods available in the scheduler queue. So that's a handful of lines of code, but almost all of them are doing simple update, insert, and delete and select statements. And that's all we have to do. Some of those methods will be called by the scheduler servers. Some will be called by the Exago web interface. So I just want to pause and see, are there any questions there so far? Awesome. I don't see any questions, but as I close this out here, what we'll do is I'll leave a little bit more time for questions. But before folks depart, I want to encourage you to do a couple of things. First, I want to say thanks for attending. I hope this lab will be really useful as folks try the scheduler queue on their own. So it will be available on our downloads page. If you log into our knowledge base and go to download like you would to upgrade a version, if you scroll down, you'll see some extensibility examples, and amongst them will be the scheduler queue example. The second thing I want to mention is our upcoming labs. So since we're covering the scheduler queue right now, in June, we're going to revisit the scheduler from a end user perspective. And particularly, we're going to highlight a couple of sort of interesting configuration features that you can turn on and enable that maybe aren't there by default or have been added more recently that you might not know about. So we're going to revisit that. And then in July, and this is what I'm very excited about, one of my colleagues is going to be presenting a series of support labs. So we're going to do more than one support lab in July, and it's going to be about our upcoming major release, our v20.1. And the key part of that upcoming release is going to be what we call storage management. I won't spoil too much of his thunder, but it's a very cool component that reworks a feature we've talked about in labs before called folder management. We're going to be doing an overhaul and upgrade to that system. So we're going to be talking through what those changes are, how they impact you, what you can do with them now in terms of permissioning, and what that upgrading process looks like for a couple of different scenarios based on how our clients have configured Exago. So we're going to do a series of labs to cover all that content so that we don't have to jam it all in one, but I'm really excited about that. So hopefully you'll share that enthusiasm with me. So just before we close out, I want to see if there are any other questions here. Yeah, okay, so just to reiterate the question about saving changes. So there's a flag in the code itself that will allow you to control whether or not you want a schedule to be updated when the report it's looking at is also saved. By default, our code example is going to say yes. And when a user saves a report, what will happen is that will be called by, that will trigger the web interface to call the method update report, and this will let the queue know, hey, a user's just updated this particular report. You should update the corresponding XML in any jobs that use this report. So that will happen by default using our sample code, but there's a Boolean here, so you can set that to false, and you can skip this step if you don't want schedules to be updated when a user saves a report. Or if you want to do something sort of more unique and custom, you can make changes, of course, to this method. Oh, a great question came here about, can we migrate current schedules to the database? The answer is yes, absolutely. So currently, if you look in a scheduler instance, the schedule files themselves are going to be, they're going to be wherever you've configured them, but the default here is going to be in a working folder. You're going to see these XML files with kind of gnarly looking names. And these are the job XML. And you could migrate these into the database. You could either write a script to do it. If you only have a few, you could do it manually. If you want some assistance with that, always encourage folks, whenever you have questions about these things, or you want a second set of eyes, take advantage of our services team. So you can open a ticket on our knowledge base that says work with services, and we'd be happy to help walk you through what that migration would look like in a little more detail. See a few more questions coming in. So question was, do we need to use extensibility for this to work? So you don't need to use the scheduler queue. The scheduler installations will handle the scheduled jobs on their own. But as I mentioned earlier, if you don't use the scheduler queue, the scheduled jobs will, if I just back up here for a second. Oh, for the update flag in particular. I see. So the question is, will the schedules be updated if a user saves the report without using the queue? Yes, the schedules should be called. If a schedule is down while a user updates a report, obviously the Exago web interface can't call that scheduler to say, hey, this report's been updated. So this would be one advantage of using the queue, is that you don't have that reliance on the schedules being saved in a distributed way and all of those servers being called and notified when a report is updated. So this would be one advantage of that. Awesome. So with that, I think I'll close this out there. But again, I hope we see everyone for our labs in June and July. And in the meantime, I hope everyone is safe and well, given everything going on, and happy reporting.